Do you know that around 180,000 people die each year because of burns? Severe skin injuries are global health concerns, and how could they not be? The skin is the largest organ of the human body, and it's the first line of defense against pathogens, protecting our organs, muscles, and bones. The traditional treatment of burns is based on grafts, a medical procedure where a healthy patch of skin is taken from the injured person's body and placed over the injured zone for it to regenerate. They have great functionality and aesthetics. The problem, they are limited by the availability of healthy areas in the patient. Imagine someone that got severe burning in half of their body. What can be done then? This is where tissue engineering comes in, specifically biomedical scaffolds made from polymers. Yep, like construction ones, biomedical scaffolds act as temporary structure for the cells to grow and proliferate. Just as buildings need beams, cells need scaffolding to grow. These structures are three-dimensional, porous, and made from polymers. And for the skin and tissue, it is necessary that these materials are biodegradable and biocompatible. There are many techniques being worked on to elaborate these scaffolds, but today I will talk about my favorite two, electrospinning and 3D printing. The electrospinning technique is a bit like a cotton candy machine, where liquid sugar flies out in thin jets that cool down to create those fluffy clouds. But instead of sugar, a polymeric solution is pumped through a needle connected to a high voltage. This electric charge ejects a thin jet that whips around, solidifies into a fiber of about 50 to 200 nanometers. This is 10 to 100 times thinner than a human hair. This technique is widely used because it's inexpensive and it can create a variety of scaffolds that mimic very closely the human cellular structure, which are ideal for cellular renewal. The multi-layer 3D printing is a bit like making a layered cake, but instead of cake and cream, the printing overlays polymers with bioink, which is a printable material that contains living cells of any kind. This bioink is loaded into a 3D printer of a special kind that forms each layer guided by a computer image. The technique allows for precise structural control, which also permits the construction of skin substitutes, not only the scaffolds for natural cells to regenerate. To sum up, electrospinning creates just a scaffold that's almost identical to the human body cellular environment, and it is effective and a low-cost method, but with a slightly limited precision. 3D printing, on the other hand, may be a better option for the creation of scaffolds with a specific structure and with built-in cells, but it is more costly and a bit less effective on mimicking the body's cellular structure. These techniques are already a great advance on medicine. However, there's still a lot of terrain to cover. The continuous development of biomedical engineering and sciences can mean a significant improvement in global health, providing alternatives to grafts that reduce the risk of infection and rejection, but most importantly, reduce the length of transplant lists and improve people's overall quality of life.